minus a square, squaring these terms. So we have to find the lowest degree term. So simplifying this, x square plus 2ax plus a square into a square minus a square, here a square, so remains only minus x square minus 2ax. So minus taken outside, x square plus 2ax plus a square into x square plus 2ax. You can see here, if we multiplied this both this bracket, x square into x square, x raised to 4 plus 2ax into x square into x, x cube plus 2ax cube plus again a square into x square plus a square into 2ax gives 2a cube x. Now from this two side we will find the lowest degree term. The first term has degree 4, second term has degree 3, y square into x, third term has degree 2. Here the degree 4, degree 3, degree 3, degree 2, lowest degree term is minus 2a cube into x. So equating to 0. The lowest degree term in the above equation we will get minus 2a cube x equal to 0, that is x equal to 0 since a is greater than 0. So it is the tangent at the due origin, thus x equal to 0 is the tangent at new origin. Which is parallel to new y axis. But we have put here x equal to small x equal to capital X plus a. So this x equal to 0 means x minus a equal to 0, since small x equal to x plus a. This will give you x minus a equal to 0. Hence this will be x equal to a, that is x equal to a is the tangent at the point which are we have find point of intersection a0. X equal to a is the tangent at the point a0. Since the curve is symmetrical about both the axes, so similarly we can find tangent at the point minus a0. Similarly, x equal to minus a is the tangent at the point minus a 0. Both are points lie on the curve. So nature of the that means the curve passes through this point only once times pass. So there is only one tangent. So these 2 points are a0 and minus a0 are the ordinary point where the origin is a node. Now we will find asymptote. What are the asymptote of the curve, which we have explained you in the procedure. To find the asymptote of the curve, asymptote parallel to coordinate axis. We have already studied that to find the asymptote parallel to coordinate axis, equating to 0 the coefficient of highest power of y. Here you can see that equation is y square into x square plus a square equals x square into a square minus x square, where a is greater than 0, to find the asymptote parallel to y-axis equating to 0, the coefficient of highest power of y is 2. So equating to 0, the coefficient of y square is x square plus s square, so which will give you equating to 0 the coefficient of highest power of y that is x square plus a square equals 0, that is x square is equal to minus a square, and which will give you plus or minus ai, which are imaginary, which is hence the curve has no asymptote parallel to y-axis. Parallel to y-axis. Now we have to find asymptote parallel to x-axis. From the equation you can see that coefficient of highest power of x, here x square into x square is x raised to 4 is the highest power of x, and coefficient of highest power of x raised to 4 is constant, that is minus 1. So there is no asymptote parallel to x-axis. Now since coefficient of highest power of x is constant, hence there is no asymptote parallel to x-axis. Thus the curve has no asymptote parallel to y-axis, parallel to x-axis. Then remains to check whether it has any oblique asymptote or not. To find the oblique asymptote, equation of the oblique asymptote is of the form y is equal to mx plus c. So we have to find m and c. M is the slope of the tangent and c is the y-intercept. Method is first of all we have to separate the higher degree terms from the equation. Here we have given equation is y square into x square plus a square equals x square into a square minus x square. Higher degree terms are in the equation y square into x square and x square into x square minus. So separating this and shade 5 4 xy. So higher degree terms are separating higher degree terms from the equation gives, say it is 5 4 xy, it is a polynomial of degree 4. 5 4 xy equals y square into x square minus, so it is plus x raised to 4. Put x equal to m 1 and y is equal to m, which will give you 5 4 1 m equals m square plus 1, equating to 0 this polynomial, that is 5 4 1 m equals m square plus 1 equals 0, which will give you m square is equal to minus 1. So m is equal to plus or minus I. Slope is imaginary, then you can say that there is no oblique asymptote. Thus, since the slope of the tangent is imaginary, hence the curve has no oblique asymptote. Thus, from these three property, the asymptotes, we have seen that the curve has no asymptote. It has no any asymptote parallel to coordinate axis. It has no any oblique asymptote. Now we have to find the region, in which region the whole curve lie. Equation of the curve is given as y square into x square plus a square equals x square into a square minus x square, where a is greater than 0. So y square is equal to x square into a square minus x square divided by x square plus a square. If x is greater than 0, a, since here a square minus x square, so if x is greater than a, then x square is also greater than a square. That means a square minus x square is less than 0. So numerator is less than negative. So this implies that y square is negative, and hence y is imaginary. Similarly, if x is less than minus a, since here x square plus x square, x is less than minus a, then x square is again greater than a square, that is a square minus x square is less than 0. So again y is imaginary. From this we can say that the part of the curve does not exist for x is greater than 0, x is greater than a, x is less than minus a. Thus the curve does not exist for x is greater than a and x is less than minus a. That is, whole curve entirely lie in or lie between x is equal to plus or minus a. That is, the curve does not go beyond x greater than a, x less than minus a. Sometimes we have to check some special points also. From this property we can try to trace the curve. First property we have checked, that is curve is symmetrical about both the axes. So we will try to trace the curve. Here it is origin, it is x axis, it is y axis. It is symmetrical about both the axes, that is part of the curve. Symmetry equally spread above the x axis and below the x axis. Since it is symmetrical about y axis also, so the part of the curve is equally spread left to y axis and right to y axis. It passed through the origin, and there are two tangents at the origin which we have find. The lines y is equal to x, and also other tangent is at the origin is y is equal to minus x. These two tangents are real and distinct, so the origin will be a node. So we will write here node. Then we have find the two point of intersection. The curve intersect x axis at the point 0 0, that is this point. Another point is a0, next point is minus a0. So the shape of the curve, like there are two tangents, and try to trace this curve. Look like there is four loop, two loop, four half loop. Shape of the curve look like this form. So you enjoy this program, how to trace the curve. There are some curve. Second curve you can see here. So second curve here given is નથી આવતું ને પછી શિફ્ટ કરો હજી જવા દો ના પહેલું હા second curve is given y square into a plus x equal to x square into a minus x. Name of this curve is trophoid. From this curve you can see that so I think you will enjoy this program. Next time we will meet to trace the curve in polar form. So thank you for this program and this.
SANDHAN, All Gujarat Integrated Classroom.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.